So the main thing that we're going to be looking at today is piecewise functions. Piecewise functions. Now, a piecewise function is a function defined by two or more equations. Each piece of the function applies to a different part of the domain, and this here is an example of it. F of x is equal to x minus 1 if x is less than or equal to 0. It's also equal to x squared plus 1 if x is greater than 0. So depending on what the value of x is will depend on which function that we use. So the expression x minus 1 represents any value of f when x is less than or equal to 0. So if we're talking about negative numbers or 0, we're using the top equation. Now if we're talking about numbers greater than 0, then we're using the bottom equation. So whichever values, whatever x is, will depend on which function that we use. So we're going to look at this here, this first example. We want to evaluate the function for the given values of x. Now for the first one, a, we're told that the value of x is equal to 0. X is equal to 0. So we're going to look at our piecewise function. F of x equals x minus 1 if x is less than or equal to 0. And x squared plus 1 if x is greater than 0. So when we look at this here, is x less than or equal to 0, or is it greater than 0? So which one is, so they both have 0, yes? Which one is, because since x is equal to 0, so that one makes the left statement true. X is less than or equal to 0. Well, 0 is less than or equal to 0. It makes that statement true. So we're looking at when f of x is equal to x minus 1. This is the function we're going to use because the value of x satisfied the conditions for this function here. So we'll be looking at f of 0. Well, that would be equal to what? 0 minus 1. And what is 0 minus 1? So for us here, f of 0 is negative 1. Any questions on this here? We good with this here so far? Okay. Part B. X is equal to 4. Now, which equation would we use for this one here? X squared plus 1. Because our condition was we're going to use this if x is greater than 0. Well, 4 is greater than 0, so we're going to use this function here. So we're saying f of x for this one here is equal to x squared plus 1. And now we can use this to find f of 4. Well, that would be 4 squared plus 1. Well, 4 squared is, and 16 plus 1 is. So for us here with this function, f of 4 would be 17. So whichever one, however many values of x it asks for, we'll have to find them. Any questions on any of this here? Because, again, x equals negative 1, so we look to see which statement is true. So this one here would be x is less than 0, because negative 1 is less than 0. So that means we're using our x minus 1. So here we would have negative 1 minus 1, which is negative 2, because negative 1 minus 1 would give us negative 2. Any questions on this here? Huh? Awesome. Awesome. So, Eric, which function would you use for part B?
For B, it would be x squared plus 1 if x is greater than 0.
And why do I know I'm using x squared plus 1? Because 1 is going to be greater than 0. Well, 1 squared is, plus 1 is. So f of 1 is equal to 2, and f of negative 1 is equal to negative 2. Any questions? Any questions on any of this here so far? Now, we don't have to be restricted to just 2 functions. We could have 3. Like these here. So we'll look at part 1 first. We'll say f of negative 8. And again, we're trying to see which conditional statement is met. So we have 3 conditional statements, or 3 inequality statements, because we have x less than negative 2. Negative 2 is less than or equal to x is less than or equal to 5. And we have x is greater than 5. Well, which statement does negative 8 make true? X plus 4s. X is less than 2, so that means we're going to be using x plus 4 for this here. So really, we're going to plug negative 8 in for x, which would be negative 8 plus 4. And what is negative 8 plus 4? So f of negative 8 is negative 4. Any questions on this here? Okay, let's look at number 3. So we have f of 0. So which equation would we use for f of 0? Two to the negative x, because 0 is between negative 2 and 5. So we're going to have 2 to the negative 0. Well, 0 can't be positive or negative, so it's just 2 to the 0. And what is 2 to the 0? Anything to the 0 power is always 1. It would not be 3x squared. It would still be the second one, because our statement for the middle one is if x negative 2 is less than or equal to x is less than or equal to 5. So we would have to get bigger than 5 to actually use the bottom statement, because it's just saying greater than. So here we would have 2 to the negative 5. Well, to really figure this out, we need to make the exponent positive, so we move it from the numerator to the denominator. Now 2 to the 5th, well, 2 squared is 4, times 2 is 8, times 2 is 16, times 2 is 32. 1 over 2 to the 5th is the same as 1/32. Any questions on any of this here so far? All right, let's look at the next one. Number 2, f of negative 2. Almost. So for x plus 4, x is less than negative 2. So is negative 2 included? Because it has to be equal to include it. Well, it is included in the middle statement because negative 2 is less than or equal to x is less than or equal to 5. So we're still using the middle statement. Since the middle statement has equals on either side, so the middle statement includes negative 2 and 5. The top one does not include negative 2, and the bottom one doesn't include 5. Well, we can make it positive and move it from the numerator to the denominator. And 2 squared is 4. Now for most of these, as long as the number isn't too big, the calculator can convert it over to a fraction. But if it does get too big, we can rewrite it as this here, 1 over 2 squared, or 1 over 2 to the 10th. And then in the calculator, figure out what 2 to the 10th is and put it on bottom, because that's where it stays. Any questions before we move?
So it's 2 to the negative x is the result of the negative 2 and 2. Wouldn't the negative and negative cancel?
Oh, sorry, yes. I see what you're saying now, yes. It should. I don't know why I wrote 2, because it should have been 2 to the negative. Which would have been 2 squared, which is 4. I see what you're saying now. Yep, it should have just been 2. Any other questions on this here? Number 4, we have f of 3. Which one would we use? 2 to the negative x. We're going to use it again because 3 is still between negative 2 and 5. Now this one here would stay negative. So 8. And last but not least, bless you, f of 10. This one would be the last one, bless you. This one here would be the last one because 10 is greater than 5. So we would be using our 3x squared, or here it would be 3 times 10 squared. Now what is 10 squared? And 3 times 100 is? Bless you. Bless you. And that would be it. Any questions on any of this here? Any questions on anything we've done so far? Okay. Now the last thing we want to really look at is graphing and talking about domain and range. To really see the domain and range, the values of x and the values of y that we can plug into this, we're going to look at the functions. Now the domain itself is easy to look at because we can look at what are inequalities that are stated. So they want us to graph the piecewise function, x squared minus 1 if x is less than 0, and 4 if x is greater than or equal to 0. Let's get a highlighter out. This part here is really describing the domain. So when I look at those values, well, the top one, if x is less than 0, so any value less than 0 is covered. So all of our negatives are covered, yes? But it doesn't include 0. So anything less than 0 is covered. The bottom one, anything that is greater than or equal to 0. Well, does that cover everything on the x-axis? Does that cover all my x values?
Yeah.
Well, yeah, because the top one covers everything less than 0, the bottom one covers 0 and everything greater. So that means for us here that the domain is all real numbers, because all the values of x are covered because I can put them into one of the two, no matter what the value of x is. Because if the value of x is negative, I'm using the top function. If the value of x is 0 or greater 0 or positive, we plug it in for the bottom one. Even though there's not an x, it still covers those values. We still have a y that is associated with those. We can plug. Now, the range is going to be a little bit easier to see if we graph this, if we look at the graph of it. Now, the bottom one, if x is greater than or equal to 0. Now, at 0, I'm going to already put a point. This is a good place because if we're graphing a line or graphing an equation, we need at least 2 points. Now, y equals 4 is what that equation is. Well, it has no slope because we do not have a x. When y equals a number, it is a horizontal line. It's a flat line. So, I just find where y is equal to 4 and go to the right because x is greater than or equal to 0. Because all of those values hold true. Any questions on this here so far? Because they told us that y equals 4, the bottom equations, y equals 4, is true when x is greater than or equal to 0. So I start at 0 and I go forward. And because it is equal to it, we make a solid point. Now we're going to look at the other function, x squared minus 1. Well, it's going to be less than or equal to 0, so this is going to be the left side. We're going to the left. Now, the biggest value that I know that it will go to is 0. It won't include it, but it is going to 0. So I'm going to find out what f of 0 is. So we'd have 0 squared minus 1. Well, what is 0 squared minus 1? Negative 1. So it doesn't include the point 0, negative 1, but it is going to it. It is going to it. That function, part of the function is going to this point. So at 0, negative 1, I'd come down here and I would make an open circle because it doesn't include this point, but it's going towards it. Does this make sense so far? Now, I'm just going to grab points going to the left that make the statement true. So we can say f of negative 1, which would be negative 1 squared minus 1, which is 0. So we'd have the point negative 1, 0. Negative 1, 0. And this time I would put a solid point because this statement, this number is true. Because negative 1 is less than 0, this point lies on the graph. Well, I can pick another one. I can pick negative 2. Well, negative 2 squared minus 1 would be, because negative 2 squared is 4. 4 minus 1 is 3. So we'd have negative 2, 3, negative 2, 3. And again, I'm going to make a solid point because these points that we're finding are true statements. These would work for this function. Now let's find one more. Negative 3 squared minus 1. And this would be?
8.
Because negative 3 squared would be 9, and 9 minus 1 is 8. So negative 3, 5, 6, 7, 8. It would be right up here. Now we do have enough points to get a general idea of what this graph looks like. So we can start here and go up this way. So this is the entire piecewise graph. Yes, sir. Yes. Any questions on this here before I erase these functions? Okay. Okay. Now the range, okay, so when we're looking at the range, we're really looking at the y values, the values that come out of the function going up and down, yes? What is the smallest y value that shows up on this graph? Well, it's down here, yes? -1 is the smallest value that shows up, isn't it? Is it included? Well, no. But it is the smallest value that we do have, and everything else is bigger. So we can say the range for this function is y is greater than -1. And we can kind of see that because all the values of y greater than -1 are included because of that quadratic. So that kind of gives us an idea of what the range is. Any questions on this here? Okay. I'm going to skip the next one, and I want to look at this one here. I think this might be the last one, isn't it? Okay. It's not as interesting. I was hoping it'd be a little more interesting than just a number and then equation. But when we look at this here, we want to describe the domain and range. And well, the domain is going to be all real numbers. Because the top equation says that it's for x is less than or equal to -1. And the bottom one is x is greater than -1. So everything is covered. Now, I will say this with piecewise functions, we won't have any overlap at all. So you're not going to see x is less than or equal to -1 and x is greater than -2, where they overlap on top of each other, because it would not be considered a function. So all of these here are not going to have any overlap. In the places that they could overlap at -1 here, one of them will be equal to it and the other will not. We'll have an open and closed dot along that line going up and down. Because when we talk about functions, you remember the vertical line test? If I can draw a vertical line and it crosses it more than once, 2 or more times, then it is not a function. It still has to hold true for this here, so that we can call it a function. Now the easier one out of the two to graph so that we can find our range is, well, the top one. Because at -1, the value of y is -3. And we would put a closed dot because it's saying x is less than or equal to -1. So -1 is included for this here. And we're talking about all the functions less than it, yes, all the values of x that are less than it, which are all the values to the left of this point, are all going to be what? -3. So this here would just be a straight line. Now we're going to look at the other side of this function. Now some of these points here are not going to be nice, because we have 2 to the -1 minus 1. Well, 2 to the -1 would be two to the -1 is the same as 1/2, because we have to move it from the numerator to the denominator to make the exponent positive. And 1 minus 1/2 would be -1/2. So you can make a little circle between 0 and -1 on the graph. Any questions on how we got this first point here? Now, luckily, after this here, well, it is open because, again, our statement says if x is greater than -1, -1 is not included. But we can start using points to the right because those will work. So we can say f of 0. Well, what is 2 to the 0? 1 minus 1 is? So our next point is going to be at 0, 0. We plug 0 into the function, we got 0 out. So the next point is the origin. Let's just keep going, f of 1. Well, 2 to the first is 2, and 2 minus 1 is 1. Yes. Any questions on any of this here so far? Let's look at f of 2. Well, that'd be 2 squared minus 1. Well, what's 2 squared? So we have 2, 3. Okay, now we can see it's increasing a little bit faster, yes? I'm going to do one more. I'm going to erase this here so I can look at one more. Let's do f of 2, 3. Well, that'd be 2 to the third minus 1. Well, 2 to the third is? Minus 1 is? Yep, let's go this a little bit. 3, 7. 1, 2, 3, 4, 5, 6. And realistically, this is the last point that we can actually do and still have it on this 10 by 10 graph. And I can kind of show this here because if we look at f of 4, well, that'd be 2 to the fourth minus 1. Well, 2 to the fourth is 16, and 16 minus 1 is 15. Well, that's already gone off our 10 by 10. Y'all see this here? So it's going to keep increasing faster and faster. So for this here, any questions on any of this here so far? Now this makes it a little bit funky for the range. Now there's a few ways we can write this, and I'm going to write it in the simplest way possible first. Y is equal to -3 and y is greater than -1/2. Because if we look at the range, the y values that are included, well, -3 is included. But if we notice that there is a break in the y-axis, because the next value of y that shows up doesn't show up until a little bit greater than -1/2. Because we know at -1/2 is a value, but it's not included. And then we have all the values greater than it. So we have that gap between -3 and -1/2. So we have to show that there is a gap there. And we did it by doing this here, because y is equal to -3. It includes that 1 point on the y-axis and everything greater than -1/2. Now we can also do this in what we call unions is an element of -3 union -1/2 comma infinity. Now the curly brackets, those curly looking brackets, are used if we have points. We use those if it's individual points. We use parentheses and brackets if we're talking about intervals. Parentheses are used if it is not included. Brackets are if it is included. Any questions on this here? Now we can get into the more rigorous definitions that we can say all values of y element of the real numbers such that y is an element of -3 and y is an element of -1/2 comma infinity. I mean, there's just different ways to write it, to say the same thing. And all of these here are describing the range of the function.